Hello. Good morning from Denver, good afternoon, and good evening around the world. Thank you for joining us for this plenary on international worldwide Mars missions. The 2020s are shaping up to be a very exciting time for the exploration of our solar system, in particular Mars. We have 3 spacecraft which launched this summer and more on their way later this decade. Our plenary comprises distinguished panelists from the US, Europe, the United Arab Emirates, and China, and our discussion will focus on the scientific objectives of these Mars spacecraft and their current mission statuses. The plenary will also examine how these robotic missions can prepare for Mars sample return and human exploration of Mars and their synergy with international missions that have gone before. I'd like to introduce our distinguished panelists. We have with us today Dr. Lori Glaze from the United States NASA Planetary Science Division, where she is Planetary Science Division Director. From the European Space Agency, we have Dr. Albert Haldeman, who is the European Space Agency Mars Exploration Group Chief Engineer. And from the Mohammed bin Rashid Space Center, we have Omran Sharaf, Emirates Mars Mission, or HOPE Probe, Project Director. And with us from the Chinese National Space Administration is Mr. Yang Gang, Director of Deep Space Exploration Department at the Lunar Exploration and Space Engineering Center. Thank you very much for joining us as panelists today. And I'm especially pleased to announce that we have an honored guest keynote speaker. Dr. Thomas Zurbuchen is the Associate Administrator of NASA's Science Mission Directorate, and he is responsible for the agency's science programs, including Earth Science, Heliophysics, Planetary Science, and Astrophysics. Prior to joining NASA as a professor at the University of Michigan in Ann Arbor, Dr. Zurbuchen focused on solar, heliospheric, and planetary instrumentation and data analysis. He has a master's and a doctor of physics degree from the University of Bern. And his honors include induction as a member of the International Academy of Astronautics, a NASA Outstanding Leadership Medal, and the 2018 Heinrich Greinacher Prize from the University of Bern. He can be found on Twitter at Dr._Thomas Z. And with that, I'll turn it over to you, Dr. Zurbuchen, for our keynote speech.
Thank you so much, Lisa. And thanks to the panelists for being here. So excited to be part of this international panel. Have you all looked at Mars lately? It's incredibly beautiful in the sky right now, shining bright red, and it is big. But of course, Mars has been shining on all of us and our parents and grandparents and so forth for millennia, with the same brilliance and with the same awe. In fact, we read about Mars in historic records around the world, and it is much more beautiful to all of us because we learned so much about it since, and especially also because of what we seek to learn as an international community next. That is the topic of this session, as you said, Lisa. In July this year, while many of us were under lockdown during a global pandemic, citizens around the world witnessed 3 launches of China, the United Emirates, and the United States to Mars, and all in the same month. While we will be joining NASA, ESA, and ISRO missions already in orbit and on the ground, never in history of humankind have we had the convergence of international capabilities and expertise that we now have on the Red Planet. We at NASA are proud with our partners of the 5 successful flybys, 7 successful orbiters, and 8 successful landings on the Red Planet, and it is inspiring to be leading together with ESA the first sample return from Mars in this decade. As with this experience extending over decades with spacecraft orbiting on the surface of Mars, we are fully aware of the challenges these missions pose and the different ways of addressing them. At NASA, we're exploring as one by merging our human spaceflight science, space technology, and aeronautics capabilities together to go to the moon and to go to Mars with commercial and international partners as part of the Artemis program. While our approaches to Mars challenges may differ because of our individual national scientific and engineering cultures, I believe we are united by the knowledge of the great benefits we receive in partnering internationally on lunar and Mars exploration, including sharing the burden of cost and risks, but also in sharing the awe and wonder of discovery. There are many mysteries left to reveal, and we're building closer relationships here on Earth by moving forward together with innovative and dynamic joint lunar exploration programs that will feed forward to advance our scientific knowledge for the good of civilization, and by doing so, support human exploration deeper into the solar system while improving life on Earth. Later in the panel, our Planetary Science Director, Dr. Lori Glaze, will talk about how NASA is projecting humankind's vantage point using our international campaign to visit Mars with robotic landers, rovers, and sample return missions. NASA is grateful to be able to lead these activities in collaboration with a host of nations and that are based on commonly shared principles. Yesterday, we signed the Artemis Accord of norms and behaviors to reinforce the Outer Space Treaty, and will lead to more safe, transparent, and peaceful and prosperous future of space for all of humankind. Our shared principles ensure that all data are available fully, openly, and without restrictions. Science is for all of us, not just for one nation, just like looking at the sky. Our shared principles ensure that we are good stewards of our solar system as well as our Earth. And our shared principles ensure that we treat all partners with the same value and equity and respect as we do our individual scientists and researchers. These principles ensure, as I said, that all data are available fully, openly, and without restrictions, and that at the international community, we have our core scientific discovery and exploration at heart as we making progress towards innovation and partnership and inspiration. Ultimately, what we do is not only educate, we inspire. We want to explore just like we observe Mars in the sky, together, each bringing our best to the benefit of all. I will now turn it back to Lisa and wish you a very successful panel. I will switch off my video eventually and listen to you as an audience member, just like most of us here online. Thanks, Lisa. Back to you.
Thank you so much, Thomas. That was very inspiring and a fabulous introduction to our upcoming discussion. Before we go to that discussion, each of the agencies has provided us a video that will give us sort of the context for the discussion we're about to have. So if we could go to the videos in the order that we had them arranged, I believe we have the one from the Mohammed bin Rashid Space Center, followed by NASA, followed by the Chinese National Space Administration, and the European Space Agency.
فنحن لا نعرف اليأس ولا المستحيل، فلهذا كان الاختيار على الاسم مسبار الأمل.
The UAE government wanted to inspire Emirati youth to go into STEM and wanted to create a disruptive change in the mindset when it comes to science and technology. On top of that, it wanted to use the mission as a catalyst for development within different sectors that would serve the creation of a competitive, creative, and innovative knowledge-based economy. So it's about the future of the UAE.
عشرة، تسعة، ثمانية، سبعة، ستة، خمسة، أربعة، ثلاثة، اثنان، واحد، إطلاق.
species of explorers, believers.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
We are willing to do the hard things to overcome the many challenges. This is what brings out the best in us.
We go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9, we have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2,
perseverance.
launch commit, liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
ExoMars is the joint mission between ESA and Roscosmos that will launch in September 2022. After separating from the carrier module and following an entry and descent slowed by a heat shield and parachutes, the final propulsive landing will be in Oxia Planum on Mars in June of 2023. The Rosalind Franklin rover will stand up and deploy her cameras, and then egress onto the Martian surface at the geologically oldest landing site yet to be explored on Mars. Once free of the rover, the Kozachok surface platform has a 13-element science payload to carry out meteorological, geophysical, and atmospheric chemistry observations. As ESA's Rosalind Franklin roves in Oxia, her science team will use her instruments to study the geology at the surface and in the subsurface. That will guide the use of ExoMars' first novelty, drilling down up to 2 meters to obtain the first samples on Mars below a depth of 10 centimeters. These deeper samples, protected from cosmic radiation and preserved at cold temperatures, will be analyzed on board. The instruments inside the rover's analytical laboratory drawer include the Mars Organic Molecule Analyzer, MOMA, which has a second novelty, a tool for Martian in situ analysis to assess organic content that does not suffer from the presence of oxidizing perchlorates in the Martian soil. ExoMars is the ESA and Roscosmos contribution to Mars exploration in the early 2020s.
Welcome back. Those were very inspiring videos, and I thank each of you for sharing them with us. We're going to start with some questions. I'm going to let you lead off, Amran, with your responses. Our first question to the panelists is, tell me a little more about the science and technology contribution for your Mars mission and how it interleaves with and how it builds on past international missions. Thanks, Amran.
Thank you, Lisa. And yes, when it comes to the science that the Mars mission or the HOPE probe will be conducting is basically we're going to be studying the Martian atmosphere, the relationship between the upper layer and the lower layer of the Martian atmosphere. The questions that we came up with was based on previous missions. So the questions that we came up with was based on the discussions that take place in MEPAG within the scientific community. And in close consultation with them, that's how we came up with that. In hope that once we get the answers for these questions, that future missions will also be designed around the answers that our mission will be getting, and which will be generating new questions. So basically, as I mentioned, we'll be studying basically the relationship between the lower layer and the upper layer of the Martian atmosphere at different times of the day, at different seasons. It's something that the scientific community is looking to have. And it will help us in understanding the different aspects of the Martian atmosphere and the sort of the ancient history of the Martian atmosphere. So this is when it comes to the science. When it comes to the technology, the platform that we came up with was based on a new approach, as was highlighted in the video. We had only 6 years to deliver this mission. It's the first time that the UAE sends a mission to Mars. There was a lot of things that we had to learn. The direction from the government was very clear since day one. Build it, don't buy it. So we had, and the direction was learn from others, work with others, and come up with a new model of conducting such missions with a limited budget and a limited time frame. And that's why we worked with our partners at the University of Colorado, at Boulder, and they were our main knowledge transfer partners in this mission, in delivering the mission and coming up with the new platform that's based on a simple approach of designing a platform, a unique one, that's capable of conducting a very specific mission with limited resources when it comes to actually schedule and budget.
That's wonderful. So tell me a little about your view of the potential for this to have synergy with future human exploration of Mars.
So it definitely contributes to the human efforts to better understand the red planet, and definitely the information that we'll be getting will help and benefit other missions for future planning. However, the thing that the UAE wants to get out of this mission is science is one of the main pillars in this mission and one of the main goals set by the government. And they were very clear with us since day one that it had to be unique, it had to be novel. However, the way that the UAE looked at this mission, that other nations might look at it also, more as a catalyst or a tool to create a disruptive change or a big change within a nation. The UAE government wanted to see a big shift in the mindset of the Emirati youth. They wanted to see a big shift in the mindset of the Arab youth. It's about designing and planning for the future of the UAE, the future of our economy, and also addressing the national challenges that we have when it comes to water resources and food resources. So the country wanted to build a strong science base in the country with the scientists here and engineers here capable of developing advanced systems. So it looked at space and it looked at Mars as a way or a mean to speed up that process and create the ecosystem needed for an advanced science and technology sector within the UAE. So in the future, a lot of the missions will most probably be catered to answer scientific questions. But then again, a lot of the activities taking place have to also at the same time satisfy other requirements and other goals that are linked to challenges we have on Earth. And the approach and the model taken by the UAE, which was basically based on international collaboration. If it was not for international collaboration and working with others, we wouldn't have been able to reach where we are today within the mission. Instead of doing everything from A to Z, we worked with others. We built the spacecraft in partnership with our knowledge transfer partners at, as I mentioned, the University of Colorado Boulder and also at Arizona State University and University of California, Berkeley. But then also we used the launch services from MHI, a Japanese company. We are utilizing the Deep Space Network. So this is I think what this mission will be bringing to the future mission about a new approach of doing things.
Thank you so much. So, Dr. Glaze, please tell us a little more about the science and technology contribution of Perseverance and how it interacts with the knowledge we've gained from past and current international missions.
Thanks, Lisa. Happy to. So the Perseverance rover at its heart is a mobile geologist and a mobile astrobiologist, meaning that it's really the main focus is trying to better understand the geologic history of Mars and how it has evolved over time, and then also understanding the astrobiology potential of Mars to understand whether or not at our landing site in Jezero Crater, there might be preserved evidence of the early beginnings of life that may have occurred about 3.5 billion years ago. And the Perseverance rover really builds on all of the prior missions, all of the international missions that have gone before, that have continued to provide new information, new knowledge, and new questions about Mars, and have really prepared us to be ready at this point to conduct the astrobiology experiments that we hope to conduct on the surface of Mars. Has really helped prepare us to ask hopefully we believe the right questions and bring the right instrumentation with us to really characterize the astrobiology potential of landing site in Jezero Crater. The new technologies that we're bringing along are directly related to that astrobiology goal, in that we have some complex drilling and sampling equipment on board the Perseverance rover, because actually Perseverance will be the first step in an eventual Mars sample return mission. Thomas Zurbuchen mentioned this at the beginning, that the next phase of exploration for NASA is to collaborate with ESA on a Mars sample return mission that will actually return to Mars and collect the samples that are drilled and stored on the surface by the Perseverance rover. And so this has been an incredible challenge to develop that technology to keep those samples protected and clean. It is the cleanest spacecraft ever sent to the surface of Mars. And so we're really looking forward to that next step when we can bring the samples back to Earth for study by the entire international science community.
And speaking of bringing back to Earth and future study, let's talk a little about how this feeds forward to human exploration or synergy with some of the other exploration efforts.
It's a great question, and Perseverance did have as another one of its major goals is really to demonstrate technologies and prepare for human exploration. One of the experiments that's on board Perseverance is called MOXIE, and that experiment is specifically designed to convert the carbon dioxide atmosphere of Mars into breathable oxygen. And so that will be a great experiment in preparation for human exploration that will need to make use of the local resources in order to sustain human presence. In addition to MOXIE, the rover is also carrying with it some samples of materials that would be used in astronaut suits, including the fabrics, some fabrics and some materials that would be used in the face shields and helmets. We're going to watch those as part of our calibration target for one of our instruments to watch how they respond and react to the environment on Mars, the radiation environment, the dust environment, just to see how well they can retain their resilience and help us again to make sure that we keep our astronauts safe when they eventually land on Mars in the coming decades. We also have a meteorological station on board that will take continuous measurements of the weather on Mars, which will also feed forward to understanding the environment for human exploration. And then finally, we're carrying as a technology demonstration a helicopter called Ingenuity, which will be the first demonstrated powered flight on another planet. It's a technology demonstration, and that will be an incredible demonstration to show that we can actually fly a rotorcraft on Mars, and that can also be very helpful for future human exploration for reconnaissance or access to sites that might not be as accessible on the ground.
Thank you so much. Mr. Gang, I'd like to learn more about the science and technology contribution and how it collaborates with information we've learned with past and current missions at Mars.
Thank you, Lisa. And in terms of the engineering technology, Tianwen-1 mission completes orbiting, landing, and roving in one mission, breaking through a range of key technology, in particular solving a range of design problems that meet various technology needs. It also provides new solutions for more efficient and low-cost Mars missions. It adopts a strategy of first orbiting and then landing. At the early stage of orbiting, the orbiter will switch positions to enhance the flexibility of landing. In terms of the scientific exploration, Tianwen-1 carries out both orbiting and landing at the same time. Some similar payloads are on both the orbiter and the rover to compare and complement each other with the corresponding detection date at the same time, such as the camera, spectrometers, radars, magnetometers, and so on. The mission will systematically study the Martian soil, ranging from the global distribution of soil types, subsurface structure and materials components, to the detector of soil structure profiles, soil materials components, and soils in the local air of the Mars. Meanwhile, it will conduct more in-depth research on the magnetical fields and other related environments of the red planets. The orbiter carry energy particle analyzer, oil and natural particle analyzer, magnetometer, which can implement the joint exploration of fields and particles for system-meter study of the atmosphere, ionosphere, and its interaction with solar wind. revealing the characters and evaluation of the environment of the red planet. Thank you. Thank you.
Thank you. Let's talk about human exploration. How does this mission relate to future exploration endeavors and support sending humans to Mars or into the solar system?
Thank you. The human advantage lies in cross-border association and comprehensive judgment, sometimes including actual institution. However, robots have executive ability in the harsh environment of the Mars at a low cost, and the development of various technologies, especially the intelligent technology, make robots more and more capable, so that the robots can achieve higher detection efficiency and even go deep in inaccessible area under humans' commands or even guidance, achieve unprecedented results. Thank you.
All right, Dr. Haldeman, please tell us more about the scientific and technological goals of the European Space Agency's upcoming Mars missions.
So ExoMars is a technology demonstration mission and a science mission. It has 4 technological objectives, which simply stated are to land on Mars, to rove on Mars, to drill on Mars, and to analyze those samples on Mars. Combined with that is the evolution of ExoMars over the last decade and a half, has paralleled, the scientific objectives are in parallel or synergistic with those of NASA's missions and the Chinese mission, as well as the orbiting missions like that of the Hope probe. So when we land, our ambition is to search for evidence of life, and to do that we have to characterize the geology of the landing site. What we will have that's novel with our mission is that the selection of the landing site is already somewhat older than the other landing sites selected so far. That's important for the science that we share with all the Mars exploration, in that the surface of Mars represents a very old surface in the solar system of a terrestrial planet. That age of rock is not exposed in very great quantity on Earth. So when we explore Mars, we're exploring the Earth. We're learning about the early days of planetary formation like that of the Earth. And because we have the evidence of water and organic molecules from the earlier missions, like Curiosity, we expect that studying the relationship of the organics in that geology could give us hints about how life got started on Mars, if it did, or perhaps what the process was on Earth. So that's the main link. And for that, we have the tools of drilling deeply, and the NASA contribution to the German-led French cooperation of the Mars Organic Molecule Analyzer probe, which we will use on site also, which we've had to keep very, very clean. And the laser desorption mass spectrometer component of channel of MoMA avoids one of the difficulties that has been facing the analysis of organic molecules on Mars in situ, which is the oxidizing perchlorates in the Martian soil. And so we're going to take that step forward, standing on the shoulders of all the predecessors, and this time around also join the company of countries and space agencies, this time in cooperation with Roscosmos, and we intend successfully landing on Mars.
That's fabulous. Thank you. And the final question to you is, how does this feed forward to human exploration? What is the synergy there?
So yeah, human missions to Mars are indeed a long-term goal for both NASA and ESA, and I assume other ambitious space agencies around the globe. The know-how developed by all of these precursor robotic missions is what we need. We need to build on the experience of Perseverance, of the Hope probe, of Tianwen, and ExoMars. And that is sort of those elements, the steps, the things, the people who build those missions, the things we learn is the know-how we need to expand the human presence into the solar system. Mars sample return will be a next step cooperation between NASA and ESA. That will be the first round trip to Mars with the ESA contributed Earth return orbiter. But what we're really doing is building international know-how for exploring beyond Earth. And what's really inspiring also in this panel and in the videos, it's the machines so far, just the machines go to Mars, but there are hundreds or thousands of people on Earth who contribute to these missions, and that's the know-how. It's the human know-how and the excitement that all of those people feel in achieving Mars exploration that really is I think the main contribution that we all achieve with these robotic missions.
Thank you so much. So we have about a minute or so left, and I have a question from the audience. So I'm going to put this out to whomever wants to answer it. So everybody, jump in. Why is it so important to bring samples back from Mars? Why is that a priority for international community? I throw that to. I see Lori reaching for her mic. Go for it.
It's okay, and then others can add. But as we've shown, as the world community has shown with other samples that have been returned in the past, for example, the Apollo samples from the moon, bringing the material back here to Earth kind of gives us, changes the landscape for what we can do with our scientific investigations. The laboratory capabilities that we have here on Earth are much more complex and larger and more capable than what we can send to the surface of another planet. We're sending very capable instruments, but there's still so much more we can do here on Earth with the capabilities we have here. And in addition, once we have samples back here on Earth, they can be preserved for decades to come, for generations, for future generations of scientists to study using new technologies that we haven't even dreamed up yet. So bringing those samples back here is absolutely critical, and a sample return mission allows us to characterize that location and know exactly where the samples came from to understand the context for that more detailed analysis back here.
Thank you. Never has a moderator more wanted to answer a question herself. Anybody? We have just a few seconds before I thank you all and send us off, everyone else off to the next panel. Anybody have anything to add to the sample return topic?
I'll just add that doing the robotic there and back again is the first step to figuring out many of the elements that will be necessary to go to Mars with people and bring them back. So it's a necessary step in figuring out getting that know-how that we all have the ambition to achieve to expand the human presence into space.
Well, thank you all. I think that's a great way to wrap up this panel. We are looking at science now, science in the future, fully international collaboration of working with others and developing the know-how and technologies and scientific data we need to eventually send humans as well. This has been a terrific opportunity for me to speak with and learn from all of you, and I appreciate your time and your participation today.